Welcome to Math 095, Metric Conversion and Dosages. This is the first of two videos dealing with operations with fractions and decimals. I imagine that the first mathematical concept that you learned was the concept of counting, and you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, counting by ones. But when you got to 10, you did not learn a new symbol. Instead, you were introduced to a new place, a place known as the tens place. Putting a 1 in the tens place meant that you had 110. And if you put a 0, which was probably also a new symbol to you, in the ones place, it meant there were no ones. So you kind of got the concept of 0. That 0 means nothing, no ones. 110. That's how we write 10. One other thing to note is that to go from 1 to 10, you multiplied by 10. If you move from right to left, if you multiply a 10 by another 10, you reach the hundreds place. Multiplying by another 10 gives you the thousands place, and we could continue, and we will later in the course, but not today. And all of these numbers that we have talked about so far are known as whole numbers. If you were an older sibling as you were growing up, you knew all about the glorious world of whole numbers and whole chocolate chip cookies. But there may have come a time when suddenly you were forced to learn the concept of halves or fractions. Those fractions can be written as numerals to the right of a decimal place. If moving one place to the left of a given place value column means you're multiplying by 10, then doesn't it make sense that moving to the right one place would mean dividing by 10? And when you do that and divide 1 by 10, you get 1/10. So this is the tenths column, followed by the hundredths column, followed by the thousandths column. Yes, I'm spitting all over my mic. Followed by the 10,000ths column. Now, why would that be important? Well, let's say someone asks us to write down 4.1 centimeters. I would assume, and probably be correct, that the way I wrote it on the whiteboard here is what they intended. However, as you're in the process of figuring out dosage calculations, it may be that you have some fractions and some decimals, so you want to convert either everything to fractions or everything to decimals. So 4.1 we could also read as 4 and 1/10, which could also be written as 4 and 1/10. There, we have our fraction. Well, we have it as a mixed number now. So we probably should do a few more of these and then talk about how we represent mixed numbers and fractions in lowest terms. Let's look at 0.17. Now look closely at the bottom of the screen. If your screen or the window in which you're viewing this is small, you might have a hard time seeing that little itty-bitty point I put there. And that's why I use this convention when I'm teaching. I will always try to remember to put a 0 in front of the decimal point. So if you see a 0 to the left of a number, look for that decimal point. Looking back up at our place value chart, the 1 is in the tenths place. The 7 is in the hundredths place. So we could read this as 17 hundredths and rewrite it as 17 hundredths in fractional form. Notice that the number we're talking about has no whole portion. There's only the fractional portion. So here are the whole numbers to the left of the decimal and the fractions to the right. That's a pure fraction. One more example. 207.023 equals 207 and 23 thousandths, or 207 and 23 thousandths. Same number, and it may be pronounced the same way, whether it is a decimal number or a mixed number. All right, let's move this aside for a little while. So I've given you examples of going from a decimal number to a fraction or a mixed number. What happens if we need to go the other way? What if we need to figure out what 2/5 is as a fraction? Well, think about the division symbol. Doesn't that kind of look like a numerator and a denominator separated by a fraction bar? Division is exactly what a fraction bar means. Therefore, we would write 2/5 as 2 divided by 5, which you can do on your calculator, or you could do it by long division. How many times does 5 go into 2? Well, it doesn't. We could write a 0 there. All right, but let's definitely put a decimal point here, and 2 is really the same number as 2 and 0/10. So we can put a 0 there. Now, as soon as I have located where this decimal point should be, I'm going to rewrite it just above it in my answer when I'm doing long division. And now I can ignore the decimal point that I originally wrote. Now, how many times does 5 go into 20? It goes in 4 times. 4 times 5 is 20. Subtract, no remainder. So 2/5 is equal to 4/10. All right, let's try converting an improper fraction to a decimal number. Now, an improper fraction is just a fraction whose numerator is bigger than its denominator. So what would this look like? This would be taking 7 and dividing it into 11, or dividing 11 by 7. That 7 goes in there one time, leaving us 4. Now, if we add a decimal point here and right above it, we can add zeros and we can just keep going and going and going. So where in the world do I stop? The answer to that is it depends upon your measuring device. It depends upon how precise you need to be for the medication you are administering with the syringe or the weight measurement or however you're doing it. It will be very specific to your application. But for the moment, we can talk about how once you know to which place you're supposed to round, you can do that. And by the way, this just keeps on going for quite a while. But for the most part, in this course, you will be rounding to the tenths, the hundredths, or the thousandths place. So let's see what this number would look like first if we rounded to the tenths. So anything beyond that will not be reported in our final answer. However, we will use this number to determine what should happen to the last number that we will report. There are different ways to round. The most common way to round, which we usually mean when we say rounding, is if this last number here that we're looking at is 5 or more, then we add 1 to the previous number. So this would be 1.6 if we rounded the number to the tenths place. If we rounded to the hundredths place, we would be looking at the 1 to determine how to report that 7/100ths. Since the 1 in the thousandths place is less than 5, we would report 1 and 57/100ths. Likewise, rounding to the thousandths place would involve going out to the 10,000ths place, where we see the 4, and determining whether or not to round up based upon the value of that 4. And the answer is no, because 4 is less than 5, so this would be reported as 1 and 571 thousandths. Now, I did say there are different ways to round. Later on, we'll talk a little bit about pediatric dosages. There are some other times also when it would be much worse to give too much of a medication than too little. So in those cases, you would always, always, always round down. And some hospitals, some places where you will work, will have their own rules of rounding for different situations. Let's just take a look at these numbers. What would happen if you always rounded down? So if we rounded down to the tenths, we would never round up, basically. We would just keep the 5 as it is. We call it rounding down, although the number doesn't change, because we're going to the number below what we have. Okay, so 1.57. We're now looking here. Rounding down, it would remain 1.57, as would the last one, 1 and 571 thousandths. So 1 and 5 tenths, 1 and 57 hundredths, and 1 and 571 thousandths. Are there cases when you might want to round up? Yes, there are. Perhaps you're talking about giving a nutritional solution, okay, Ensure or something. Then it might be perfectly fine to get more of it in the patient than what is strictly needed. In those cases, you may be instructed to round up. However, in this course, if you are not specifically told to round up or to round down, just follow the normal rules of rounding. Okay, for this specific number, though, if you are always rounding up, for the tenths, 1 and 57 hundredths would become 1 and 6 tenths. 1 and 571 thousandths would become 1 and 58 hundredths. And 1 and 5,714 ten thousandths would become 1 and 572 thousandths. All right, let's look at some special fractions like 15 hundredths. We have already mentioned hundredths. What is 15 hundredths equal to when you do the division? 100 goes into 15. Well, it won't go in there, so we have to put a decimal point and a 0. Put the decimal point there. It goes up here for my answer. All right, I have 1 times 100. And I do the subtraction, and I get 50. I will need to bring down another 0. So 100 goes in there 5 times. 5 times 100 is 500. So 15 hundredths is equal to 0.15, but as I told you, we read this as 15 hundredths. You could have gone ahead and done that, couldn't you? Just reading it there. Notice what happened. We went from 15, and we did our division, and we got 0.15. Look at what happened here. There was an understood decimal point here after the 15, and we moved it 2 places to the left, which brought it here. And I put the 0 in the front to indicate that there is a decimal point there. We moved it 2 places to the left. We were dividing by 100, which has 2 zeros. What would have happened if we had divided by 1,000? If you go over here or you punch it into your calculator, you will find that you get a movement of 3 places from its original spot to the left, because we divided by 1,000, which has 3 zeros. What would happen if we multiplied 15 times 100? 15 times 100, 0,051. That equals 1,500. Where did the decimal point go? It started here, and it moved 2 places to the right because we were multiplying by 100, which has 2 zeros. If we multiplied 15 by 1,000, which has 3 zeros, we would be taking that 15 and we would be moving the decimal point 3 places. So we would wind up with 15,000, which makes sense. 15 times 1,000, 15 thousandths. Okay, but what if we started with a different number? say if we started with 0.015 and multiplied by 1,000. Well, let's go ahead and write it here. We're going to move the decimal point 1, 2, 3 places. So the decimal point is now here. So we now have some whole numbers. To the left of the decimal point, we don't need these zeros. And since we don't have any numbers to the right of the decimal point, we don't really need the decimal point either, do we? And look at what we got. 0.015 times 1,000 equals 15. Does that look a little familiar? Hopefully it does, because compare that to this. 15 divided by 1,000 equals 15 thousandths, and 15 thousandths times 1,000 equals 15. All right, let's hold on just a little bit, and let's go back and look at our 15 over 100. Let me get rid of, let me get rid of this other stuff here. Take me just a moment. Because 15 over 100, or 15 hundredths as a fraction, does equal 15 hundredths as a decimal, but it is equal to so much more conceptually also. Because when you look at it, you have 15 over 100. You are doing a division there. And what are you dividing by? You're dividing by 100. So actually, you have here 15 per, because that is what a division bar means, or what per means. It means you're dividing by something. And what are you dividing by? Cent. Cent as in century, 100 cents in a dollar, centurion, centennial, all those things that remind you of 100, because that's what it means. 15% literally means 15 divided by 100. Okay, so we can move between all of these expressions. 15% equals 15 hundredths equals 15 hundredths is a decimal, 0.15. And there are some common fractions for which you should memorize their percentages. 3 divided by 4, or 3/4, is equal to 75 hundredths, which is equal to 75%. It is the same amount of something expressed as a fraction, a decimal, and as a percent. So what does our very special number 1 look like? That looks like 5 divided by 5. That is 1. And if you went ahead and wrote 1 out to the hundredths place, you would have 100%. Okay? If you had, I don't know, 7/5, what is that as a decimal? Did we do that one yet? Well, 7 divided by 5 is 1.4 as a decimal. So, and look at what you do. To go from the decimal form to the percentage, you're moving it out 2 places to the right. So this would become 140%. And you can check this. 140%. If you divide 140 by 100, yep, you will get that. And here's a thought. If you reduce 140 over 100, you will get 7/5. Can you have less than 1%? Of course you can. Just as you can work from percentages to decimals or fractions. So let's look at 0.3%. Okay? When you do this, whatever the number is, even if it's a decimal, that is what you will write in the numerator, 0.3, and this percent, okay, there's the 0.3, the percent is here, as in per cent. Okay. What is that? Decimal over a 100. Okay. What happens if you divide by 100? Okay. Dividing by 100, remember, moves the decimal place 2 to the left because you're dividing. Okay. So this will be 0. Oh, and I'm going to put a 0 out in front. Okay. This one has disappeared. Oh, there went part of my 0 also. Okay. So 0.3% is equal to 0.003. Okay. You can look at things like 30%. That's equal to 0.30. 70% is equal to 0.7. 0 or not. Okay, so 0.4 would be equal to what? It's 4/10 or 40 hundredths or 40%. Okay, your book gives you some more practice. I think we've done enough of this for now. Thus ends the first part of operations with fractions and decimals. Look for part B.